All right, let's dive into something that's pretty much invisible, but it runs our entire world, computer networks. Whether you're cramming for a test or you're just kind of curious how you're even watching this right now, you are in exactly the right place. We're going to make this super simple.
You know, we saw this comment, and honestly, we get it. The pressure is on. That exam is right around the corner, and you just need the main ideas, like right now.
So, just take a deep breath. For the next few minutes, think of us as your study buddy. We're in this together, and by the end, I promise, you won't just get the basics, you'll probably be able to explain them to someone else.
Okay, so where do we even begin? Let's start with the biggest, most fundamental question of all. What actually is a network?
That's it. No, seriously, that's the core of it. At its heart, it is just that simple. It could be your laptop connected to your printer, it could be your phone talking to your smart speaker, or it could be the billions and billions of devices that make up the internet. The only words that matter are connected and sharing.
So, if a network is just a bunch of connected things, what are the actual pieces? What are the essential building blocks you need to know about? Let's get into it.
First up, we've got something called a node. Now that sounds super technical, I know, but it's just a fancy word for any single device that's on a network. Your phone is a node. Your laptop is a node. That smart TV on your wall? Yep, it's a node too.
Next up, the link. So how do all these nodes talk to each other? Well, that's the link. It's the how. It might be a physical wire you can actually see, like an Ethernet cable plugged into your computer. Or it could be totally invisible, like the Wi-Fi signal you're probably using right this second.
Now, let's talk about the two main hats a device can wear. It can be a client or it can be a server. Think of it like this. When you open your web browser to watch this explainer, your device is the client. It's requesting the information. And the huge, powerful computer somewhere out there that holds the file and sends it to you, that's the server. It's providing the information.
Okay, so we've got the parts. We've got nodes and links and clients and servers, but how do they actually talk? How does your request for a video travel from your laptop all the way to a server and then come all the way back? Well, here's a wild thought. The network doesn't just send a whole file in one giant, heavy chunk. Can you imagine how slow and clunky that would be? No way. Instead, it does something way smarter. It breaks the information down into thousands of tiny, easy-to-manage little pieces called packets. It's kind of like sending a massive encyclopedia one page at a time. And this is where the real magic happens. Every time you click, your request is instantly chopped up into these packets. Each tiny packet gets stamped with a destination address. Then a device called a router acts like a super fast traffic controller, figuring out the best path for each packet to take across the internet. And they might all take different routes, but they all get to the destination, get put back together in the right order, and then the server does the exact same thing to send the video back to you. And this all happens in, what, a fraction of a second? It's incredible. Now, for all this beautiful chaos to actually work, every single device on the planet needs to be playing by the same set of rules. They all have to speak the same language. And that language, the official rulebook for the internet, is called TCP/IP. It's the grammar that makes sure everyone understands everyone else. So how do these packets know where to go in the first place? That's where the IP address comes in. It's really simple. Just like your house has a unique address so the mail carrier can find you, every single device on a network has a unique IP address. It ensures the right data gets to the right device.
And who's directing all this traffic? The router, that little box with the blinking lights in the corner of your room. It's basically a traffic cop for your data. It looks at the IP address on every single packet and points it down the fastest, most efficient road to get where it's going.
Okay, so now that we have the building blocks, let's zoom out a little bit. Because the coolest thing is that these exact same principles apply to the tiny network in your home just as they do to the entire global internet. You're going to hear two main acronyms a lot, LAN and WAN. First, the LAN, or Local Area Network. Think small. This is your home Wi-Fi network or the network at your school or office. It's contained, it's fast, and you probably own all the gear. Then you've got the WAN, or Wide Area Network. This is the big stuff. It connects lots of LANs together across huge areas, like a whole city or even a country.
And that, right there, brings us to the big one, the internet. It's not some magic cloud floating in the sky. It's just the biggest WAN there is. It is quite literally a massive global network made up of millions and millions of smaller networks all connected to each other. A network of networks. Okay, exams coming. time for a super quick recap. If you're studying, this is the moment. Let's lock in the key terms you absolutely have to know.
Here are the big acronyms. LAN is local, like your home. WAN is wide, like the whole world. IP is the address for your device, and TCP/IP is the rulebook that makes it all work together. Got it? Good. Feel free to hit pause here and jot these down if you need to. And here it is, the ultimate summary. If you can explain these 6 concepts, you have a solid, fantastic foundation in computer networking. A network connects nodes. A router is the traffic cop that directs data using an IP address. The whole thing works because of the rules of TCP/IP, and it all happens on small LANs and giant WANs. Boom! That's the core of it right there.
So there you have it. You're ready for that exam. But you know, the story of computer networks is really just getting started. Every single day, billions of new devices are coming online, from our watches to our cars to our coffee makers. So the real question isn't just how it all works. It's as everything becomes a node on this global network, what are we all going to build next?